welcome to this video. My name is Joker, software engineering student in Macquarie University, and I'm here to take you through how we are going to make money, or how we are going to try and do some business with the current system we are building. It's an AI system that translates real-time Uganda Sign Language to clinical slot translation for infectious disease triage. Yeah, so stay with me and then we'll look at it. So we need to first understand how the system works. So I'm going to take you through in a second. Now it's working currently on our system. Yeah, so let me take you quickly through the system, how it works locally on our machine, and then you may fall in love with it. So this system, we have implemented the video processing in two ways, using the live camera, and then assuming in a situation where a patient is unavailable, but then they have recorded their videos explaining their symptoms and stuff like that. So the doctor can upload the video and then get what the patient is going through and stuff like that. Yeah, so we can upload a video. Right now I can't do a live camera stuff because I'm using it for recording this video. Yeah. So once you upload the video, the patient, and then you process. But when you're processing, you have to come to this site of clinical results to see the output and so on. Cough, no, 100% sure, diarrhea, no, and stuff like that. This is the part for the video processing. When it's processing the video, it shows everything here. And then this is for avatar synthesis. This is used when you talk back to the patient. So they can use this, they can type here, do you have fever? So once we can generate, see how the synthesis understand. You fever have, cough, blood and stuff like that. That's the gloss, and then you tap that, and then the avatar will translate it back to the deaf patient. Right now we haven't implemented it yet, but we're going to be implementing anytime soon, so that once you guys contact, we can give you the fully working system. Yeah, so that's how the system works. And then the red flag detection, remember we uploaded the video and everything was low, so the triage assessment is low, and then so it means we can't tap on emergency. Once it's high, we can tap on emergency, or call clinician, those who are in charge of taking care of such a condition, so we can call and stuff. And then we can generate report from the video we uploaded and stuff. We can generate that report. Yeah. This system works in different languages: English, Runyankole, and Uganda. So those are the languages. And then the system analytics for generally the things that are working in the system and stuff like that. So on the side here, you can see the form for the patient. This one is supposed to be filled automatically based on the clinical results. Fever, yes, cough, blah blah. So it's not yet implemented. Once we implement this, anytime this results pops up, it's also going to work on this, and then the possible results, priority diseases, these are the ones. So it's going to bring up the one that is actually the patient is suffering from. So that's it. So we need to look at the problem space. The core problem we have right now is that deaf patients cannot communicate symptoms in sign language during infectious disease screening, and this leads to misdiagnosis or delayed triage most of the times. And looking at who suffers, over 500,000 deaf Ugandans, they suffer with this when they go to the hospital. And then rural clinics with no sign interpreters, they also suffer with this. And high burden diseases like malaria, tuberculosis, and cholera, and so on. These diseases, they normally get to take over these people, and they normally get wrong treatment and stuff because people don't understand what they're saying. And then why are we bringing AI into this? We know that human interpreters they don't stay at the clinic or hospitals 24/7. So we need a system that will be there 24/7. And then most times these interpreters, they don't understand non-manual signs, facial expression. How system will be able to understand such kind of signs and so on. And then the impact of this system, our target is to reduce intake time of deaf patients by 60% and prevent outbreaks via early danger sign detection. So the system detects early signs before it escalates. And then who are the users? The primary users of this system are the deaf or hard of hearing patients, nurses and triage clinicians. And then the most important people we need to work with are Ministry of Health Uganda, the deaf community, and then district health officers and NITA Uganda, the governments, to approve the system rules. Data, we're going to get data. We're going to collaborate with UNAPD signers to help us with data to make a specific Uganda Sign Language data set. And then the developers that are going to do with is the POS plus graph attention model team. We are going to also do, and then validators, the deaf community, they should review the system if it's working accurately or not. And then with the data source, the data type that we'll need is the video that will be extracted, and then gloss annotation, the pause, and the media pipe will be used for extracting the pauses, and then the gloss annotations for those gloss mapping to sign languages and stuff. So sources, from the source we have 100, actually it's supposed to be 4026 Uganda sign language medical videos that we have got. And then we also got Ministry of Health screening templates, and then we fixed it in the system. Open post or media pipe extracted skeletons. We are also dealing with that. And then pipeline, we'll do collection of data cleaning, and then annotation, and then we store in the form of with the extension of NPZ. And then going on the side of the ethical and privacy, the government will approve the system based on Uganda Protection Act of 2019, and no video of the patient will be uploaded to the cloud. It will be only on a device locally and offline, and then the device will extract on the skeletons and frames and stuff, and leaving along the videos for data privacy. So the value we are offering, the system will deliver accurate slot filling. For example, fever. If someone has fever, yes, it will mark that automatically. Cough, no, stuff like that. And this will lead to life-saving triage, so that we prioritize serious diseases early to prevent escalation and so. And then the solution our system is offering, we extract frames from videos, and then graph attention, it gets the most important note from the extracted frames. So for it doesn't deal with sequences, it deals with importance, or where it's supposed to put most attention at a given time. So from input to output, the input is Uganda Sign Language video. The output will be structured slots in the form of fever, yes, cough 5 days, and speech, text to speech in Luganda and Nyankwele, and then avatar signing when clinician is trying to communicate back to the patient. And then so our system handles red flag detection. It's supposed to detect if a patient has a serious condition, and it detects it before, so that the patient is prioritized and taken seriously and given early treatment before the condition worsens. So the key metrics: the post-extraction extracted 31.8% of the videos, and we got 123,355 frames from the 31% of the videos extracted. And then the graph attention network, after training from the frames, went to 57.1% in validation accuracy. The best epoch achieved 66.7% in accuracy. So what we are trying to achieve is that 80% of deaf user should be able to trust the system and find it useful to them. If our target is met, and we also want to reduce time intake during disease screening by 60%, and the system will ensure privacy of every patient, so that no data is shared with another patient and no one else can have access to that. And this system will be deployable in over 100 rural clinics where there are no interpreters. And then we will partner with Ministry of Health, so that it increases the reach, so that other people or other deaf patients can also have access to the system. So with this system, we are the first to produce Uganda Sign Language system that translates on Uganda Sign Language, and with graph plus logic layer for skip logic. For example, if a patient has been having fever for like 5 days, we can skip the other part, and then we go straight to asking if about if that maybe coughing blood or having diarrhea and stuff like that. Yeah. So that's what we're trying to achieve. But we have 4,026 Uganda Sign Language videos currently, and then it's the domain-specific screening ontology which is aligned with the one for Ministry of Health, and the system will work offline and in a low resource areas where people don't have access to expensive resources, like maybe those expensive computers and stuff. They can use it on their tablets, which increases accessibility for almost everyone. And then channels and distribution. We are going to take advantage of Ministry of Health pilot programs, so that we go in different hospitals. When they approve the system, we go in different hospitals and we try to see if they're going to adapt the system or not, and if it is so, and then you're going to use the deaf community to get more reach. And Makara Health Tech, we're going to do Makara Health Tech demo, like the one you're doing right now, and more others to come, so that they get to see the value of the system. And then we're going to produce APK that works offline, as I've already told you before, an API for EHR integration. And then we're going to get community feedback after giving them the system to try it out. We'll get their feedback if the system is working the way they want, and so on. And then we'll keep on doing monthly model updates from user data. We'll keep on doing that to improve user experience. And then we should also talk about the revenue streams. We'll have free basic models given out to community clinics, these small clinics, so that they can be using that to get more reach. And then premium versions for the API and analytics dashboard for district hospitals that want, they can maybe acquire that at a cost. And then the system should be licensed by the Ministry of Health, NGOs, and telemedicine platforms. With that, we can also gain something from it. And research grants, funding from World Health Organization or USAID, and then for anonymized triage trends, we can also give them our models so that they can try them out and so on. And then resources we need. So right now we already have AI engineers, me and my team, and deaf community for validating the system, and then user experience UX designers, Ministry of F. And then for the technical part of it, we are using MediaPipe for extracting the frames from the videos, and then PyTorch plus PyG, and Android Studio for developing the APK for the Android systems, and then data, Android plus Uganda Sign Language medical videos, and then Ministry of Health screening forms will be implemented in the system so that we get things in a standardized form as required by the government or the Ministry of Health. And for the part of the financial, the University plus Ministry of Health pilot funding will also need that so that we can go for those piloting in different way, different hospitals and stuff. So key activities, we'll always keep on updating the models now and then so that users they get accurate translation based on their feedback. We are going to keep on upgrading the system to meet their needs and so on, because it's not about us, it's about people who are going to consume or people who are going to use the system. That is more important. So that's what we're going to be doing. Then key partners, Google for MediaPipe and PyTorch. Data will partner with UNAPD, the deaf community, Ministry of Health for screening templates, ethical oversight. We'll get approval by the IT approval by NITAU. And then the distribution, we're going to use we're going to deal with Ministry of Health teams to help us get more reach with this system. And then Infectious Disease Institute, because it's more focused on that side, as the system name sounds too. And then we will need 8 million Uganda shillings for data for collecting real Uganda Sign Language data, videos for training the model, and for compute cargo GPU for training, and it's free. And then for humans, me and my team, and that's stipend. Those designers, we're going to give them some bit of incentives for what they will be doing. And then you need 2 million for marketing and getting approval by RB to make the system legal in the country. So the government will need to approve the system first before clinics or hospitals can start using them. And then we'll keep on adding we'll keep on doing bias audit. Model card model card will be published, and confidence scores based on explainability, attention maps will also be declared. And then legal, Uganda Data Protection Act will also be will also play part in the system so that patients know that their data is safe and secure. And in the scalability, we're going to build a small system on small devices, and then we are going to take it from Ministry of Health. Ministry of Health adoption, and we're going to the money we're going to generate from there. We're going to use it to keep on maybe getting more data for training and keep on upgrading the system. And the first thing we're going to do is first to make the offline version of the system, because we are targeting majorly those rural areas with low resources and stuff. So they need the offline version first, and then and backup models will also be available. So talking about intellectual property, protectable assets, Uganda Sign Language medical screening dataset, and graph attention logic layer pipeline, patentable process, and screening ontology with skip logic. So the system will be focused on Uganda Sign Language as a screening dataset for only disease screening, and the graph attention layer for giving out the right prediction and screening ontology with script logic for getting more details of the symptoms that the patient is trying to display. And the team contribution, this is what me and my team members did on the system. And so right now, what we have completed is getting 4,026 Ugandan Sign Language videos collected. Post extraction pipeline. We have trained graph attention network, the model, with 57.5% accuracy on average, and this can increase with more data. And then in progress, we are building the APK for the system for Android and stuff. And then avatar integration, it's also in progress. And the next steps, we'll try to complete the graph attention network training, and we'll try to afterwards we'll try to do piloting in 3 rural clinics to see if the system is giving out the right translation and stuff, or performing its purpose. And we'll add avatar signing model, and then we'll partner with Ministry of Health for scalability. So if you have any questions, let me know in the comment and I will get back to you, or you can contact me on either of those numbers, or just send me email directly.